Good evening to all of you. This is Anand Babu. Today we are going to discuss about the biomolecules topic. This is also one of the important topic for EAMCET and other competitive examinations, and discussion again on NCERT. So listen carefully and understand the concept and get perfection. Before starting our program, Unacademy is the best educational platform to you, enables you to make perfect in your studies, and also you have opportunity in Unacademy having a number of free live classes, YouTube, and also special classes. So through which you have interaction with experienced educators. I am the educator of EAMCET. So this is the right platform to you, guiding you and to go reach your goal successfully. And so here, don't forget my referral code Babu Live. So you will get 10% discounts on subscription of Plus. Here you see, there are plans, monthly and yearly plans. So this is a very good offer to you, affordable price available. So make it as useful, and also share your experience with your friends and recommend to join in this group. So already many people experienced with the teaching of the Unacademy here, educator. So here separate batches will be there for you. So there is a chance of choosing educator in relevant subject. So all of your doubt clarification. So this is the platform so that you will be perfect, and also to test your performance and in attempting the answers in the examination. Tests over the syllabus will be conducted, and also number of quizzes in rapid manner also here can be conducted by educators. So be alert in all aspects and take subscription of plus subscription. Okay, thank you very much for coming and participating in this program, those who are watching. And shall we start now our program on biomolecules? Okay, this is the first question for you. The four elements called Big Four, which make up 95% of all elements found in a living system. Living organisms, plants and animals are made up of 95% made up of which elements? Here, majorly they are present. Okay, which body construction will be there. So 95% here. Okay, found in living are carbon, hydrogen, oxygen, nitrogen. Second option is carbon, hydrogen, oxygen, phosphorus, carbon, hydrogen, oxygen, sulfur, and carbon, nitrogen, oxygen, phosphorus. Which is the right answer here? The right answer is direct question. It is carbon, hydrogen, oxygen, nitrogen. These are the components of biomolecules, carbohydrates, proteins, and lipids. These are biomolecules made up of carbon, hydrogen, oxygen, nitrogen. Biomolecules means carbohydrates, proteins, lipids. Okay, so this is the right answer. Next, coming to another question. The organic compounds like sulphate, here is a sulphate and phosphate, this are found in. Here given options are acid soluble pool, acid insoluble fraction, both A and B, D none of these. The right answer is here A, acid insoluble, soluble pool here. Acid soluble pool means if you observe the elements or some other substances inorganic, organic, present in living bodies here. We will conduct simple test. That is, for example, tissue from leaf or from liver is taken and it will be grounded well. After grinding here, whatever by adding trichloric acid here. So you will be getting how many fractions? 2 fractions. One is acid soluble fraction and acid insoluble fraction here. Acid soluble fraction here, biomolecules, macro and micro. Okay, acid soluble fraction means acid soluble, micro molecules, micro biomolecules, here macro biomolecules. Okay, micro biomolecules. Under this acid soluble fraction and sulphate and here phosphate. Both are coming under acid soluble fraction. In acid soluble fraction, smaller molecules, amino acids, and also what is the sugars. Okay, like this, amino acids. Okay, like this, nucleosides. Okay, another bit here. So the right answer is acid soluble pole consists of the sulphate and phosphate. Another question here. How many carbon atoms are usually used in composition of monosaccharides? Monosaccharides. Complex carbohydrates are generally saccharides. Complex carbohydrates are generally saccharides. Why? Because basically they are sugars. These are saccharides. Okay. Basically they are sugar here. And monosaccharides here. Monosaccharides. Here is the right answer here, A, 3 to 7. Depending on the number of carbons, monosaccharides are trioses and tetroses. Am I correct or not? Tetrose, pentoses and hexoses and heptoses. So these are all. For example, trios, how many number of chromosomes? Carbons here 3C, 4 carbon. Here 5 carbon, here 6 carbon, here 7 carbon. Okay. So trioses example, can you tell? Glyceraldehyde 3 phosphate like this. Tetroses erythrose. Okay. And 5 carbon pentose, here ribose or what is that? Deoxyribose. And hexo means here 6 glucose. And here hepto means 7. That is pseudoheptulose. So like that. Depending on the number of carbons, here monosaccharides are classified trioses, tetroses, pentoses, hexoses, heptoses. Okay. 3 to 7 carbons. Here up to 7 I gave you. Okay. This is the right answer. Next, coming to which of the following is correct match here? Acidic amino acids, basic amino acids, neutral amino acids in the following. A, B, C options are there here. Under acidic amino acid, glutamic acid is given. Under basic amino acid, lysine. Neutral amino acids, what is valine? Here like this, lysine. And glutamic acid, valine. Glutamic acid, valine, lysine. Lysine, valine, glutamic acid. Under that, which is the correct match here? Correct matching here is A only. Glutamic acid is a lysine. Example for glutamic acid, acidic amino acid. And this is what is called basic amino acid. This is valine, neutral amino acid. So here is given acidic amino acid and basic amino acid and neutral amino acid. Here in zigzag manner is given, see, lysine. Lysine should be where? Lysine should be under basic amino acid. So this is wrong. Am I correct? Glutamic acid. Glutamic acid should come under what? Glutamic acid, neutral amino acid. Okay, here under acidic amino acid is given. This is also wrong. Lysine also like this. Okay, do you understand now? Acidic amino acids, basic amino acids, neutral amino acids. What is the difference? Do you know? I will tell you here one time. Acidic amino acids have 2 COH group and 1 NH2 group per molecule. Select the pair that consists of acidic amino acids. Here how many amino groups are given? 1. And here 2 carboxylic groups are given. 2 carboxylic groups are given. and 2 amino groups are given. So it is a acidic amino acid. But one point you have to remember, acidic amino acid is nothing but amino acid. Number of acidic means COH more. Here 2. Here amino group only here only 1. So carboxyl group are more, no. So it is a acidic amino acid. For example, basic amino acid means, for example, amino groups are 2 and carboxyl group is only 1. So it is, what is it? Basic amino acid. Neutral means, and carboxylic group and what is it? Amino group. Both are same. Number is same. So it is neutral, it is basic amino acid, it is amino acid here. Okay? Are evolving. So here the given is, question is, acidic amino acids have 2 COH group, 1 amino group per molecule. Select the pair that consists of acidic amino acids. In which of the 4 options here, acidic amino acids. What are acidic amino acids? Here the right answer is aspartic acid, glutamic acid is correct. Okay. These are acidic amino acids. Acidic amino acids. Here, lysine, arginine, basic amino acid. Here, glycine, these are neutral. Neutral amino acid. Okay. This is the correct answer. So, these are wrong answers. Next, coming to next one. An example of aromatic amino acid is. What is aromatic amino acid here? That point you have to understand. What is aromatic amino acid here? So I will tell the example here. Tyrosine is correct only. Phenylalanine and also tryptophan. All this is correct. All of this. For example, tyrosine is here. Aromatic amino acid means hydrocarbon containing what is that ring structure like this. Ring structure will be there. Here, for example, if we take a tyrosine here, in tyrosine, actually it will be like this. Okay. Here OH group, and here what is it? CH2, CHNH2, and here one more COH. Sorry, here you see. Here you see, this is a tyrosine structure here, hydrocarbons here attached with a ring structure here. So like this. If there is no ring structure, it will be called as phenylalanine. A phenylalanine also having ring structure, but OH is not there in phenylalanine structure. Okay, tryptophan is there. Tryptophan also hydrocarbon containing ring structure. If ring structure is there in the hydrocarbon, that is what is called aromatic amino acid. Example for aromatic amino acid: tyrosine, phenylalanine, tryptophan. 3 are examples. Next, coming to essential amino acids include. Essential amino acids include. You know very well essential amino acids, non-essential amino acids. What is the difference also you know very well. So what is the answer here? Essential amino acid. Yes, A correct, B, D. All of this. Essential amino acids and non-essential. This is essential amino acids. These are non-essential amino acids. Non-essential. Okay. What is the difference here? Essential amino acids cannot be synthesized by body. I mean, we should get essential amino acids from the diet only. From diet only. But non-essential amino acids can be synthesized by body. Body can synthesize. Body can synthesize. Am I correct or not? That is. So, essential amino acids should be available from the diet only. What are essential amino acids? Many people they feel difficulty in memorizing. That is, I remember that essential amino acids are non-essential. So there is one plan here, easy way to learn essential amino acids. What are non-essential amino acids? So here M I will write P, T, V, I, L, L. Here you see M stands for methionine. Methionine. This is phenylalanine. Phenylalanine. Okay, this is what is it? Tryptophan. tryptophan. Here valine. Here is the isoleucine. Here leucine, and here lysine. So easily you can write this one. MP, TV, IL. You remember this. And non-essential amino acids here A3, aspartic acid, okay, aspargine, okay, and alanine, and G3 also, glutamic acid, glutamine, okay, glycine, and also STP, better write STP here. STP means what? Serine. Okay, tryptophan, what is it? Tyrosine, and P stands for here proline. Okay, easily you can remember this. MPTVIL. This is for essential amino acid. Non-essential amino acid A3, G3, STP. So that you'll be able to remember very well. But here tyrosine, T is a remember tyrosine or tryptophan here. Here T stands for tyrosine. That only difference is 1 or 2 are there. So, do you understand? Okay, thank you. Next, which of the following statements about amino acids are incorrect? Essential amino acids are not synthesized in the body, therefore they are to be provided. It is correct only. Leucine and isoleucine, valine are essential amino acids. Okay, it is also correct only. Cysteine, methionine are sulfur containing amino acids, correct only. Lysine and arginine are no. Lysine and arginine are what? Tell me. Lysine, basic amino acid. Arginine also basic amino acid. Here also basic amino acid. This is incorrect. So, okay, in 4 options, the D is wrong here. Instead of basic amino acids here, these are different here. These are basic amino acids here. Okay. Next, coming to another video. Which of the following is a saturated fatty acid? Saturated fatty acid. Under this, oleic acid, linoleic acid, arachidonic acid, palmitic acid. The right answer here is okay. And this is the right answer. D is the right answer. Palmitic acid. Saturated fatty acids means important by which, how do you identify saturated fatty acids? Without a double bond. No double bond. Without a double bond. Am I correct? That is first point. Saturated fatty acids are, what tell me? Boiling point is very high. High boiling point. Boiling point is very high. So, saturated fatty acids, what are they? Containing mostly cholesterol. Am I correct or not? And here one more important point here. Palmitic acid is the example. Palmitic acid, stearic acid also. Stearic acid. Here the palmitic acid contains 16 carbons. This contains 18 carbons here, including carboxyl group. Here CH3, okay, CH2, 14 here COH, including this carboxyl group. First 1 carbon, here 14 carbons, 14 plus 5, 1, 15, here 16. So that is palmitic acid. Like that here, in stearic acid, here 16 should be there. So that comes to 18 carbons. So next, coming to another. Which of the following is triglyceride? What is triglyceride? How it is formed? Here the triglyceride example, oil. This is triglyceride. How this triglyceride is formed here? For example, glycerol. Directly I will write here. Glycerol plus 3 fatty acids. I mean glycerol esterified with 3 fatty acids. That is nothing but a triglyceride. Triglycerides are formed. Triglyceride or triglycerol. This is formed. How it is formed, I will tell you. Here, glycerol, what is the structure of glycerol? CH2 and here CH and CH2. Okay, am I correct or not? COO, H, R1, here R2, here also R3. 3 fatty acids here. Okay, and 3 fatty glycerol. This is the structure of glycerol with acid. Here, gives rise to. CH to CH, sorry, CH. Here is it. Okay. This is R1, this is R2, this is R3. Okay. So it is 3H2O. Okay, this is. Here, just to see, this is what is called glycerol. This is what is called. Okay, this glycerol, sorry, what is it? Triglycerol. Triglycerol. This is triglycerol. Okay, this triglycerol is formed by the what is that? Glycerol plus 3 fatty acids. R1, R2, R3 indicates the fatty acid. This is glycerol structure. So here, what happens? This gives rise to this one plus here. Okay, triglyceride. So this triglycerol is nothing but oil. Which type of oils are there? Sunflower oil, okay, mustard oil, and groundnut oil. Okay, hard fats. These are all examples for triglycerides. Okay. Another question for you. And lecithin is, what is lecithin here? Lecithin is nothing but it belongs to group that is phospholipid here. Phospholipid. This phospholipid is a triglyceride here. Phospholipid, what is that? Phospholipid here. Phospholipids, 2 glycerol, okay, plus 2 fatty acids here, not 3. Okay, 1 fatty acid is replaced by phosphorus. I will tell you, CH2, okay, and CH here, CH2. So here R1 COOH, COO, this is R1 here, okay, this is R2, 1 fatty acid, this is another fatty acid here, and 1 fatty acid replaced by phosphorus here, phosphoric acid, better to say phosphoric acid, okay, and also it contains one more additional compound, that is what is called, you see, so this point you have to understand here. Okay, so this is you have to remember this one. So here phospholipid structure, this is one. These are all esterified with 2 fatty acids. 1 fatty acid is replaced by the phosphoric acid, and also one more additional compound here. One more additional compound. This is one more additional compound. This is phosphoric acid. So this is about lecithin structure here. Okay. Another important. The polysaccharides made up of glucose monomers are glucose monomers. What are monomers here? Monomers are units of the polysaccharides here, and monomers here I will tell you: chitin, glycogen, and cellulose. Made up of glucose monomers. Glucose monomers mean here you see monomers of monosaccharides here. For example, in this structure, glucose, same molecule is repeated. Glucose molecule is repeated. Okay, here chitin, glycogen, cellulose. All are homopolymers, no? Homopolymers only. In homopolymers, the glucose units will be repeated here. In case of what is it? Chitin in glycogen. No, sorry. This is not starch. Glycogen and cellulose. This is the right answer. Starch, glycogen, cellulose are made up of glucose molecules only, no? But glucose molecules are repeated here. Okay. Monomers of monosaccharides here. Homopolymers. Okay. Starch, glycogen, and cellulose. Study the given statements and select the correct ones here. Cellulose is homopolymer of glucose. Yes, it's correct. Inulin is homopolymer of fructose. Right. Starch gives blue color and glycogen gives red color with iodine solution. 3 are correct only. So fourth, none. Here is given. So here cellulose is homopolymer. You know very well what is homopolymer. Already I told you one monomer of the monosaccharide repeated. Same monomer repeated here. That is what is called glucose here, glucose. This is what is called cellulose. Inulin is homopolymer of fructose here. Fructose, same here, repeated here like this. So more than one monomer is not there here, only one type. Inulin is what is that? Reserve food material in asteraceae member. But fructose is nothing but a smallest oligosaccharide. It is smallest polysaccharide, better to polysaccharide. Smallest polysaccharide fructose. Inulin is a homopolymer of fructose. Fructose is smallest polysaccharide. Inulin is reserve food fed material, reserve food in asteraceae members. In asteraceae members, inulin is a reserve food. Starch gives blue color with iodine. Am I correct or not? Starch here is there. It will contain iodine here. Iodine in helices, iodine. So the iodine receives what? Iodine and turns blue color. Blue color. Am I correct or not? Starch only I1, I2 molecules will be there in starch, in the structure. And next coming to another question. Which of the following is heteropolymer here? See, heteropolymer. Cellulose is not, it is a homopolymer consisting repeated monomers of monosaccharides. Here you see starch, homo. Glycogen also here, homo, polysaccharide. This is peptidoglycan is a heteropolymer. That might have to be. Heteropolymer, this is heteropolymer. Okay. And another one. And which of the following is not correct regarding the chitin here? Chitin. Under these four options, one is not related to this chitin. It is a storage polysaccharide. It is a homopolysaccharide. It is a constituent of arthropod exoskeleton and fungal cell wall. It is the second most abundant carbohydrate on the earth. Yes, correct. So this is only the wrong one. It is a storage polysaccharide. No, it is not storage polysaccharide. It is homopolysaccharide. Correct only. Okay, it is a constituent of arthropod. Homopolysaccharide, same unit will be repeated in the polysaccharide here. It is a constituent of arthropod. For example, take cockroach, exoskeleton, that is made up of chitin. Okay, it is very hard structure generally, exoskeleton, and fungal cell wall also. Okay, it is also what is that? Okay, next, it is the second most abundant carbohydrate. Which is the second most abundant carbohydrate means? That is chitin only. Another question there. Purines have nitrogen atoms in the position. Purines means what? Tell me. Right answer here, 1379 positions. Here purines means adenine and guanine. These are purines here. That point you have to remember. For example, they have what? How many? This one. Two, what is it? Dicyclic ring it is. Here you see 1, 3, 7, 9 position. Okay, nitrogen will be there. Nitrogen. Here nitrogen. Okay. Adenine, guanine are the purines here. Purines dicyclic ring they contain, and at 1379 position nitrogen will be present, nitrogen element. Okay. But in here you see adenine, guanine, cytosine, thymine, these are pyrimidines. Pyrimidines are the monocyclic rings, only one cycle. But nitrogen are 1, 3 positions. Here you see 1, 3 positions in what is it? In cytosine, thymine. I mean pyrimidines. Next, coming to another bit. Primary structure of protein is due to the presence of primary structure, secondary structure, tertiary structure, and quaternary structures. So 4 types of structures are there in a protein. So in biological language here. But here the right answer is primary structure, peptide bonds only. So this primary structure of protein tells only the arrangement of the amino acid. Amino acids all are arranged in a particular fashion, in linear manner. Here you see bond present between these amino acids is called peptide bond here. But this structure, primary structure, helps only about the position of amino acid. It tells about the position of amino acid. Position only. And which amino acid is first amino acid, second amino acid, third, which is first, which is second, like that. Position only tells. It will not explain biological function. It is not important for biological functions. Okay, that is peptide bonds only here. Disulfide bonds means cysteine, methionine. Okay, cysteine. Okay, these are disulfide, having disulfide link. Hydrogen bonds in the secondary structure of the protein it will be. Okay, ionic bonds, tertiary, and also quaternary. Okay. Next, coming to an alpha helix is the example of which type of protein structure here: primary, secondary, tertiary, and quaternary. Here the right answer is secondary only. Alpha helix means the polypeptide which forms spiral like this polypeptide, and polypeptide is stabilized by hydrogen bonds. Okay, stabilized by hydrogen bonds. All hydrogens are arranged, okay, like this, parallel to the polypeptide here. So this forms what is it? Spiral. Okay, this is secondary structure one. Alpha helix it is. Two polysaccharides here. Okay, and hello. Okay, hello. I am from Vijayawada. Next, coming to another question. Enzymes catalyze the biochemical reactions by activation energy. Here, enzymes, what is the relationship enzymes, presence of enzymes and activation of energy? For example, take one reaction without enzymes. These are reactants, A, B reactants. This is product here. No enzyme is present here. So activation energy is something here 400 kilocalories. 400 kilocalories. This is what activation energy required for this particular chemical reaction. Interacting this what is it? What are the reactants and forming a product here. 400 kilocalories of activation energy. In absence of this enzyme, in presence of enzyme here, you see here, enzyme is present here. So reaction will take place. I mean, product formation will take place even with 50 kilocalorie of energy. Only 50 kilocalorie of energy. I mean, activation energy is very, very low here in presence of enzyme. Do you understand? So enzyme presence is very important. Even with provision of less amount of energy, the reaction will take place and form a product. So lowering energy. Okay. Another bit here. Which of the following statement is incorrect regarding enzyme activity here? It increases with the substrate concentration, which is incorrect. Right only it is. It is highest at optimum pH value. Oh, it is also correct. And it initially decreases with the increases in pH value. Initially increases with increase in temperature, and this is also correct. And it is initially decreases with increases on pH value. This is wrong. Okay, but one point you have to remember, the enzymes are very active. The pH here 7 here, pH 7. Below this and higher this pH. Optimum level of pH for the activity of enzyme is 7, neutral. But below this acidic, and above this 7 here, this is basic. For example, so all enzymes except few are active under pH. Optimum pH is 7 here. But for example, you take pepsin here. Pepsin, its optimum pH only here 2. I mean acidic pH. This is acidic pH, they are active. And here trypsin you see here. Trypsin, this 8 point, see here 8.8 like that pH. So excepting few, all are active under pH 7 here. And another important point, Michaelis-Menten constant Km. Okay, that is equal to, what is the answer here? So in Michel's Minton constant here with the substrate concentration here, half in the substrate concentration. The rate of reaction half in the what is that maximum velocity. This is maximum velocity of rate of reaction. This is half in the rate of reaction here. So Michel's Minton constant tells that what is that? This is half in the maximum velocity, half in the rate of reaction of the maximum velocity here. So there will be relation between enzyme efficiency and substrate concentration. The substrate concentration increases up to here half. So enzymes are active here. Beyond that, enzyme activity decreases. Why? Because enzyme amount becomes less here. Okay, that point you have to understand. So substrate concentration of which reaction attains half its maximum velocity. This is what is called Km. Next, inhibition of succinate dehydrogenase by malonate succinic dehydrogenase. An example of, for example, you see here succinic acid here. And for example, if we take succinic acid as substrate here, so the substrate structure is similar to the structure of water, malonate and also succinic acid. Succinic dehydrogenase. Okay, this is succinic dehydrogenase enzyme. This is succinic acid and malonic acid also. So both the structures are actually malonic acid reacts with succinic acid. Succinic dehydrogenase here. But similar structure is there, no? So it will compete. The succinic dehydrogenase is competing with the malonic acid. So what happens? Reaction will not happen here. Structural similarity with the substrate and enzyme. So that is responsible here. And feedback inhibition means in a particular kind of reaction, product is formed, no? So to control the production of product here, these are reactants. Reactant 1, reactant 2 here, and here. Okay, so this is enzyme here. So product inhibits the enzyme that is important for the initiating first step of reaction here. In the first step of reaction, the conversion of R1 to R2, this enzyme is there. This enzyme activity will be suppressed by product here. That is what is called feedback inhibition. Feedback inhibition is important to control the amount of product. Proteinaceous molecule that joins a non-protein prosthetic group to functional enzyme. Okay, apoenzyme or cofactor. Proteinaceous molecule, that is what is called joins a non-protein prosthetic group to form a functional enzyme. Yes. Here one enzyme is there, no? This is enzyme. Okay, sorry. This is enzyme here. What is that? Protein part. This is non-protein part. This is protein part. This is non-protein part. This non-protein part is called cofactor. Okay, this is a protein part, apoenzyme, which is called. This apoenzyme, cofactor, both together called holoenzyme. Okay, this is given on holoenzyme. Here, this is the right answer. Okay. Zinc is a cofactor for proteolytic enzyme, that is carboxypeptidase. Carboxypeptidase is a cofactor of what? Zinc is a cofactor of carboxypeptidase. Why? Because these cofactors are very, very important for the activity of enzymes. Enzymes are very active in presence of this cofactor. It may be zinc or molybdenum, other ions also. Okay, that is the right answer. As coming to enzymes are most functional within the temperature range of, this is the temperature, 25 to 40. If we take this graph here, taking y, here like this. So here enzyme activity is more at 40. Optimum temperature is 40. Beyond 40, again enzyme activity decreases. That point you have to understand. Enzyme activity is optimum, highest at 40 degree. That is the maximum range. That is optimum temperature. Beyond that, again enzyme activity decreases. So suitable temperature required for the activity of enzyme is 25 to 40 here. Any other? The protein which has in the rate of given metabolic reaction, it's not necessary. Cytidine is a nucleoside. Cytidine is a nucleoside. Cytidine means cytosine here plus either ribo sugar or deoxyribo sugar. Deoxy in DNA. Here is the deoxyribo sugar. Deoxyribo. So it is giving what? Cytidine. Cytidine is nucleoside. When phosphate is added to it, so it will be called nucleotide. Am I correct or not? Nucleotide. Okay, ribonucleotide or deoxyribonucleotide. This is deoxyribonucleotide. Why here? Sugar is a deoxyribose. Okay, last but not least, the 20 different amino acids have different functional groups, R groups. 20 amino acids are there, no? What is the structure of amino acid here? This is R group, and this is okay, COOH, and amino group. Here is alpha carbon, here no hydrogen. So like this 20 amino acids are there, okay, different arginine, okay, amino acids are there, no. So R group is also different. 20 different amino acids have different R groups. R group is changing here only. COH amino group are common, hydrogen, but here only R group is changing. So in the place that amino group may be there, or hydroxyl group may be there. Sorry, hydroxyl group may be there. So depending on that, amino acids are called with different names. Okay, thank you very much. Thank you for your cooperation. Thank you for your patience. Next day after tomorrow we'll meet again with another topic. Okay, thank you.